Hi guys, this is Math 148. Math 148, section 9.1, looking at limits. So in each of these videos, I'm going to cover some of the essential topics in each section and work some of the problems that illustrate these topics. So section 9.1 is limits, and it's a heady sort of topic with weird notation, but it's essentially saying where is a function going as it's moving towards a certain point. So I think of it like a roller coaster. For example, let me show you this problem. Here I have a fancy graphing calculator. Here's a fancy function here, x squared plus 5x, blah, blah, blah. But suppose you just look at the graph, and if we zoom in, we see that this asymptote, sorry, I was zooming out. It's all going down at x equals -1. So the question might say, what is happening to this function as x approaches -1 from the left side? Well, from the left side, it turns the corner and it heads to -infinity. And from the right side, if we're coming at the function this way, I think of it like two trains. One train is approaching from the east and one is approaching from the west or whatever. As you're approaching coming down this way, you start to approach -1. So here's -1. Right? What happens? It goes boom, and the train shoots and goes up to +infinity. So the way you would write this mathematically is you would say the limit as x goes to -1 from the left of this function equals -infinity, and the limit as x goes to -1 from the right, you see what I did there, of this function equals +infinity. And the function is, what was that function? It was kind of a mess. I didn't want to rewrite it. I think it was x squared plus 5x plus 6 all divided by x plus 1. X squared, something. Yeah. So, again, here's some notation I want to introduce you to. You have x approaches some function, and this negative sign means from the left. So it's not -1 negative, it's approaching -1 from the left. So suppose you have a function here. This function will not be as nice. All my functions are normal curves. And there's some point C. Ding, ding, ding. Here's a point C. You're saying what happens when you're approaching that point from the left? This is the limit of C from the left. It's weird, it's negative, but in my mind that's going forward. And then suppose you wanted to approach that point from the right. The notation we use is that's the limit of C from the right as x approaches C from the right. So I think of this positive. In my mind, I think of that as going backwards, which doesn't really make sense because there's not necessarily a forward and backward orientation in functions, but that's how I think of it. So negative is going the regular way from the left on up, and positive means you're approaching it going backwards. Okay, let's look at a piecewise function and how this would work. So question number 29, this is on page 554 in one of your homework problems, where the function is a piecewise function. So you have f of x equals 10 minus 2x, this line, if x is less than 3, and then as soon as x equals 3 or more, it pops up and turns into this parabola. So you have a piecewise function, and suppose you want to know the limit. What is the function doing as x goes to 3? So the limit as x goes to 3 of f of x. So they're basically saying, where is this function going from the right, and where is this function going from the left? So the way you work these functions is you say, well, let's plug in x equals 3. So let's take the limit as x goes to 3 from the left. So sort of, this is going to be a terribly scaled, here's 3. That's the point 3. So from the left, we have some function here. It's coming down. That's supposed to be a straight line. It's this thing. So we have the function is 10 minus 2x. Well, at 3, we can plug in the value 3 and see where is that function going. So that's going to be 10 minus 6 is 4. So that tells us that as x approaches 3 from the left, it's going towards a point 4. That would be 4, right? Okay, 4. All right, so what's happening on the other side? Suppose, what is the limit as x goes to 3 from the right? Again, I think of it as going backwards, so we're approaching 3 backwards here. And I think this is downward facing parabola, so I'm going to make it up, people, but it's going to do something something. Let's try it. So we plug in 3 here, 3 squared minus 3. So I'm saying on the right side, I'm dealing with this piece of the function. So I have 9 minus 3 is 6. So I'm saying on the right, it's approaching 6. Is 6. 6. So I have some function and it's, boom, you know, approaching like that, maybe. So the problem here is on one way, the function is coming down and it's approaching 4. But when you come the other direction, the function is approaching 6. I will show you that on a real graph and not my silly graph. My graph isn't really able to do the piecewise function, or at least I don't know how to program it on this free app thing. So here's x equals 3 is this line right here. I'll draw that in for you. Just need this green line. So basically our function is coming along, it's the red line, ding, 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 boom, and when it hits x equals 3, it hops, it goes pop, and it pops up to the blue line and keeps going. So it goes red line, red line, red line, red line, red line, red line, pop, and then it pops up here and keeps going. That popping is not good as far as limits are concerned. So this is discontinuous. So the problem, when you look at this equation, you say it's 4 going towards 4 on one side, 6 on the other side, so the limit does not exist. So what we're saying with this question is there one point where you can say as x goes to 3, is the function approaching one point? And the answer is no, it's approaching 2 different points, depending on which direction you're coming from, so the limit does not exist. Again, I think of these limits, it's like a train. Is there one station that the function is going towards? Nope, it's heading toward 2 different stations, so the limit doesn't exist. Let's look at another problem where we do this algebraically. Sometimes these limits algebraically without graphing them. So question number 15 says find the limit as x goes to -1 of 4x cubed minus 2x squared plus 2. And suppose you don't want to bother with your graphing calculator and look at the 2 directions and see where the train is going. So you can say, well, this is a polynomial, and according to the rules of this section, when you have a polynomial, so it's just a straight, you know, adding and subtracting these different x's with different powers, you can plug in the value. The answer is the limit, the rule, says that the limit as x goes to -1 of, notice it's just x going from either side, I'm not picking a side this time, of this function equals the function evaluated at the point -1. So we plug in 4 times -1 cubed minus 2 times -1 squared plus 2. And this is true because polynomials are continuous, so they just kind of skip ahead there. So that's 2 times -1. Look what I did, you guys. I made a mistake. That's minus 2 times 1. Ooh, minus. Plus 2. Many points are lost every year across America for people like myself that don't get their negative signs correct. So minus 2 plus 2, -4. So the answer is -4. So what is the limit? -4. So if you have a polynomial, you can just plug in this value and that will give you the limit. You don't have to mess around with the graph. I'll show you a fraction one, which is a bit more complicated. So question says find the limit as x goes to 10 of 3x squared minus 30x divided by x squared minus 100. So this is a fraction. You know, you have 2 polynomials, there's a fraction, so it's not quite as straightforward. And you can look at page 548, there's some rules. What do they call it? The rational functions evaluating limits in the form f of x, g of x. So here's how you use those rules. I think they're easier to understand in practice. Essentially, you say, well, I'm going to take this value 10, and the first thing I'm going to do is plug in 10 into each one of these functions. So I'm going to have 3 times 10 squared minus 30 times 10, see, 30, divided by 10 squared minus 100. This is technically doing the f of c divided by g of c that they talk about in the book. In this case, c is 10. So that's 300 minus 300 divided by 100 minus 100, which is equal to 0 over 0. So some of you are like, that's 0. No, it's 1. No, it's undefined. But what you do, wait for it, just, you know, this is the, if f of x is 0, x of 0, this is type 1. They call it the type 1. And I'm not going to ask you, is this type 1 or type 2? I'm just going to ask you to find the limit. So when you get this 0 over 0 situation, what you want this to trigger in your mind is that this can factor and you should keep going. This factors, keep going. And you might want to write this on a note card or something, but what this essentially is telling you, in case you didn't see it right away, is that this function, you can factor these things and reduce it to a form that makes it easier to find the limit. So let's pull out a 3x. That becomes 3x times x minus 10. You see that because that's 30x squared minus 30x. And then the bottom, because that's a perfect square, is x plus 10 divided by x minus 10. Like that. And now we get to cancel, which I love to do. I love to cancel. So our function, we're saying this is the same as finding the limit as x goes to 10 of 3x divided by x plus 10. And now we can plug 10 in here. And we can say, well, let's try this again. Plug 10 in there, we get 3 times 10. Plug 10 in there, we get 10 plus 10. This is equal to 30 divided by 20. I'm doing this without my calculator, people. Equals 3 halves. Whoa! So this whole big messy thing turned into 3 halves, and you do it by factoring. Or you could do it by graphing. I have the graph here. So here's the function. Do you see that? 3x squared minus x plus 10, like that. And when you plug it here, remember, if you're looking at negative 10, don't look at negative 10. Look over here at x is going to 10, remember? We wanted the limit as x goes to 10. So you look at this function, you say, what's happening at 10? Right there. I'm going to zoom in, zoom in, zoom in. So what's happening to our train as we approach the 10 station? I'm going to work on that animation right now. You say it's coming here, and you'll notice that point. Come on, give it to me. Give it to me. I want it to give me the point. It's not doing it. All right. Well, it used to be giving me the point. The point is 10 and 3 halves. So, oh well. Next problem. Next, you didn't get this nice 0, 0 situation. Let's get a new one here. Don't save. I'll make it black. You see how the magic is happening? Oops, no, it should be black. Fill with black. Sorry guys, I thought this would be magic for you. Okay, problem I want to go over. This is question number 33. We're asked to find the limit as x goes to negative 1 of x squared plus 5x plus 6, all divided by x plus 1. So again, we're going to plug in the value of x equals negative 1 and look at these definitions on page 548 of evaluating limits of the form f of x over g of x. So the first thing you want to do is plug x equals negative 1 into this. Again, this is doing an f of c over g of c. This is essentially what the book is talking about when they say that. So you plug negative 1 in. Negative 1 squared plus 5 times negative 1 plus 6, all divided by negative 1 plus 1. Some of you might just skip ahead and write this part. 0 plus 1 minus 5 plus 6, watch the negatives, equals 7 minus 5 is 2 divided by 0. Well, before we had 0 over 0, but this 2 divided by 0 is no good. This tells us that it does not factor. So there's no reason bothering trying to figure out what this factoring is. Although I'm pretty sure it's x plus, well, I don't know. I don't know if that will factor. Does not factor, and that means the limit does not exist. Does not exist. So when you get a situation where you have a number divided by 0, the limit does not exist. You can say it like this. Limit d n e does not exist. And I'll show you that on the graph. Again, we're looking at the limit of this function as x approaches negative 1. Here we are, 5x, I'm not done yet, plus 6 divided by, oops, like this. Parentheses. Why is it not giving me the right parentheses? We are function x squared plus 5x plus 6 divided by x plus 1, and we're looking at what happens when x approaches negative 1, which is right down here. I'll zoom in a little bit and scooch it up. Maybe I gotta. So as it approaches negative 1, you can see from the left side it goes up, 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 boom! It scoots down. It's the function we saw at the beginning. So it approaches negative infinity, and as it's approaching from the right, we see it's going towards, and then kind of towards this like 6, and then boom, spits up to positive infinity. So again, this illustrates the basic rule that the limit of x goes to -1, that equals negative infinity, and the limit as x goes to -1 from the right is equal to positive infinity, negative infinity, positive infinity. These things are not the same, so that means the limit does not exist. So the rule is that the limit only exists, limit of c exists, if the limit from the left equals the limit from the right. So if only exists if the limit as x approaches c from the left equals the limit as x approaches c from the right. So in this case, the functions are approaching different stations, so the limit does not exist.